In this video, I'm going to work out 3 different examples that deal with definite integrals. This first example here will be in determining the area of a region bounded by several different graphs, how you can sketch it and then use the definite integral to determine what that area is. And the second 2 examples will be just really basic trig functions with your definite integrals. Alright, so let's get started here. Let's suppose you are told that you need to determine the area of a region bounded by the graphs of the given equations. And they give you y equals negative x squared plus 3x. They give you an x equals 0, an x equals 3, and a y equals 0. Okay, my first recommendation would be probably to do a rough sketch of this right here. You don't have to be too precise, but you at least kind of have to know what's going on here. We can know that it's a quadratic, and we know that it's upside down. You could do negative b over 2a really quick if you want to know where that x coordinate of that vertex is. You could also factor it and find your zeros really quick. I think that's the approach that I want to go first here. So if I factor this, I might take out a negative x. Alright, that would leave me with an x minus a 3. Alright, set that equal to 0 so I could find some zeros here. X is going to equal 0, x is going to equal 3 for my zeros of that function. Alright, and I have a vertical line at x equals 0, and I got another one over here at x equals 3, so this is going to turn out really, really nice. Alright, so rough sketch here. Alright, I'm going to have a 0 of this upside down parabola at 0. 1, 2, 3, another one over here at 3. Okay, and we know it's upside down, so I can do a rough sketch that says my parabola is going to probably look something like that. Okay, now I've got the vertical boundary that's right here at 0. I've got the other vertical boundary at 3. Alright, and then y equals 0, another boundary is the y-axis right there. Okay, so the region then that I need to be focusing on is right here. Okay, this is the part that I'm trying to determine the area. Alright, so we can set up a definite integral here. So we're going to integrate from 0 to 3 of our function, negative x squared plus 3x, alright, dx. Okay, so nothing other than power rule on this integration. Really simple here at the beginning. And so when I integrate this first one, I'm going to add 1 to that exponent and get a 3 and divide by the 3. So I'll have a negative 1/3 x to the 3rd. Alright, when I integrate this section right here, I have a 1 here. I'll add 1 to the exponent. That'll give me a 2 and then a 3/2 there in front. So 3/2 x squared. Alright, I'm going to now integrate this on the interval from 0 to 3 rather. Alright, so we can plug 3 in. Come back over here so I've got plenty of room. Let's do negative 1/3 times 3 squared plus 3/2 times 3 squared. I think I said squared on that one. I meant cubed. Alright, and then when I plug in 0 and I plug in 0, I'm just going to have 0 over there altogether. Alright, so 3 cubed divided by 3 there is going to give me a negative 9. And then 3 squared is going to give me a 9 times 3 is 27. That'll give me 27 over 2. And then we can get some common denominators there. That'd give me a negative 18 over 2 plus 27 over 2. And then when I subtract there, I'm going to have a 9/2. Okay, so one little example there of how you can determine the area of a region bounded by some graphs, do a little rough sketch, and then work out your definite integral. Okay, now let's take a look at a couple of basic trig functions. Really basic because we're still here at the very beginning of our definite integrals. Alright, so for my first example here, let's say we're going to work out the integral from 0 to pi over 4 of secant squared x dx. Alright, so that's one of the trig functions that hopefully at this point you have memorized. Secant squared integrates to tangent x. Alright, and then this will be on the interval from 0 to pi over 4. Alright, when I go to plug this in, I will have tangent of pi over 4 minus the tangent of 0. Okay, at this point, hopefully you've got your unit circle memorized really well. All right, this tangent of pi over 4 is going to be your tangent of 45 degrees on your unit circle, so it's going to be a 1. Tangent of 0 is 0. So my overall integral there is going to be equal to a 1. All right, on the second example over here, I'm going to be integrating from 0 to pi over 2 of 2 plus cosine x dx. Okay, so don't have enough room there, so let's come down here and do this. Alright, when I integrate 2, that's going to integrate to a 2x. Alright, when I integrate cosine, hopefully again you have these memorized, that this will be a sine x. Alright, and then I will be evaluating this on the interval from 0 to pi over 2. Okay, I'm going to plug pi over 2 into both of them, and then I'll plug 0 into both of them. Okay, so I'm going to have 2 times pi over 2 plus sine of pi over 2, and that will be minus 2 times 0 plus sine of 0. Okay, so right here, let's see, the 2's are going to cross out. That's going to leave me with a pi right here. Sine of pi over 2. Pi over 2 is that 90-degree angle. Alright, so sine would be 1 right there. Alright, minus 2 times 0 is going to be 0. Sine of 0 is also 0, so I'm just subtracting 0 over there. So overall answer to this one, just simply pi plus 1. Okay, so two very, very basic trig functions. Alright, but I'm assuming that you're at the very, very beginning of your definite integrals, and seeing examples like this is going to be helpful. So thanks for watching, and if you liked the video, don't forget to give me a thumbs up.